Okay, so here is a guided talk through on how, oh dear, there we are, on how an investigation might work. So this, for a lot of you, this will be the first one that you'll have done. Essentially what we're working towards is you being able to complete what's called a paper 6 at the end of grade 10. So that's for your IGCSE, the CIM course, and there's two elements to that. One of them is an investigation and one of them is a modelling section. So we're focused on the investigation section in this instance. You can see each of the sections take about 45 minutes. There's a strong emphasis on GDC, although we're not really focusing too much on that for today, which is why you can't see mine. I'm going to just talk you through kind of how I see this and give you a bit of guidance on how to piece these things together. Okay, first tip that I would give you then is just to read really carefully the contents of the kind of introduction bit. There's always going to be a little bit of information that's given to you, and you just need to make sure you read that really carefully, because they're always trying to give you some sort of clue about what they want you to do and how they want you to approach this. So for this one, investigation look at some relationship between unit fractions. A unit fraction is a fraction which has a numerator of 1. So we can see a couple of instances of fractions with numerators of 1s. Okay, now first of all it's saying the difference between the unit fractions a quarter and a fifth can be written with a common denominator and then reduced to 1 over 20. Okay, that's fine, that's the sort of technique that we can do. The product, multiplying them together, those two fractions, we just multiply the 1s, multiply the 4 and 5, and we get 1 over 20. Okay, then it says the difference and the product of the unit fractions, a quarter and a fifth, are the same. Well, that kind of makes sense from what they've shown me, 1 over 20 and 1 over 20. So first one, part A part 1, is to find the difference between the unit fractions a third and a quarter. Now they've already shown me how they want me to present this, so what I'll probably do is try and write out in the same way as they've done here. So I need to do, and get it the right way around, a third minus a quarter, which is equal to, if we combine them it's going to be 3 and 4, so that's going to be 12. So it's going to be 4 over 12 minus 3 over 12, which is going to be equal to 1 over 12. So the difference is 1 over 12. Product is slightly easier to work out. 1 over 3 times 1 over 4. 1 times 1 is 1. 3 times 4 is 12. Same as the difference. Marvellous. Okay, find the difference and product of the unit fractions 1 over 3 and 1 over 5. Okay, so let's just go through the process. 1 over 3 minus 1 over 5 is equal to, now I'm going to have to make this 15, and it's going to have to be 5 over 15 minus 3 over 15, which is 2 over 15. Okay, difference is 2 over 15, and the product, third times 1/5, is going to equal to 1 over 15. Okay, so they're not the same in this instance, and something different obviously is happening to how it's been set up. We're going to kind of take some inferences from that in a minute. At this stage all I've done is exactly what they've asked, which is just to add or subtract some fractions and multiply them as well. Okay, over the page. Find another pair of unit fractions whose difference and product are the same. Well, let's go back and look at the ones where they were the same. So that was when it was 1 over 4 and 1 over 5, and it was also where it was 1 over 3 and 1 over 4. So what strikes me is that these are apart by 1 and these are apart by 2, and that seems to be the difference here. So that's the sort of pattern that you're going to have to try and piece together when you're doing these types of investigations. Okay, so well, let's just think about the numbers that I've done already. I've done 3 and 4. I've done 4 and 5. Maybe the next sensible one would just be to do 5 and 6 to keep my numbers as simple as possible. So consecutive numbers, 1 over 5 minus 1 over 6 will equal to, let's just see if this works. We're going to have to be over 30 and there's going to be 6/30 minus 5/30, which is 1 over 30, and yes, 1 over 5 times 1 over 6 is equal to 1 over 30. So what's it asking? Find another pair of unit fractions, so I need to write the unit fractions that I've used. 1 over 5 and 1 over 6. Okay, A and B are positive integers where A is smaller than B. Okay, so we need to think about getting the right way around. Right, as a single algebraic fraction, 1 over A minus 1 over B. Okay, so this is just now algebraically expressing exactly what we've been doing. So what have I been doing? Well, in this step here, what I've been doing is I've multiplied the 5 and the 6 to give me 30. So if I'm going to generalize that in terms of A's and B's, that would be equal to A times B. And let's just have a think about what these numbers are above in terms of A and B. If we think that if this is B, this is equivalent to B, and this is representative of B here. So B then goes here. If the A is here, the A is here, the A is here, in terms of A and B, this calculation is actually B minus A, isn't it? So I can write this as B minus A. And actually that can't be simplified, so that's going to be what I'm going to write. B minus A over A times B. And then for part 2, it's just, well, 1 times 1 is 1, and A times B is AB. Okay. A pair of unit fractions has the same difference in product. Complete the following statement. When the larger fraction is 1 over n, so let's just think about the larger fraction. The larger fraction is the first one, right? Always the first one. So with my number, it was the 1 over 5. My letter is 1 over A. And we're going to subtract the smaller one so that we get a positive result. So how do I describe this fraction relative to this one? Well, the thinking that I had to do for this part 2 was there was a difference of 1. It was 1. There were consecutive numbers on the denominators of the unit fraction. Now, if this is the larger one, then we add 1 to get to this. So I would write this as being 1 over n plus 1. Okay, sum of the unit fractions at half and a quarter. Okay, so we're moving on now in question 2 from those consecutive numbers. Now, we don't expect them to be the same, but we're going to obviously be looking at something else. So let's just see what it's guiding us into, what it's trying to show us. Okay, so the sum we've got here, and all of those calculations make sense. Numbers 3 and 4 form two sides of a right-angled triangle. Okay, so 3 and 4 appear to have come from the final result of the sum of the unit fractions. Now, the hypotenuse we can work out using Pythagoras. That's fine. This is 5. That makes sense. Okay, so there's quite a lot going on, but let's just take it one step at a time. What's it actually asking me to do here? Just find the sum of them. Let's do it. Let's just crack on and find these added together. So that's going to be 1 over 5 plus 1 over 7, which is going to equal, it's going to have a denominator of 5 times 7, 35, and it's going to be a 7 plus a 5. So it's going to be 12 over 35. Okay, fine, that's my answer. Okay, using your answer in part 1, find the Pythagorean triple that may be formed from the sum of 1 over 5 and 1 over 7. So what we're going to try and do, again, there's quite a big leap here, but I think we're okay making this. The result here were the two numbers that formed the two sides of my triangle. So let's just try that same process again. So the two numbers that I've been left with is 12 and 35. So let's try and piece that together. So it would be, if I make it look the same, 12, 35. So my thinking is, can we work out this hypotenuse? Well, yeah, we should be able to, shouldn't we? What's the square root of 12 squared plus 35 squared? Now, I probably am going to do that one on my calculator. and that's going to give me 37, and it does come out with a whole number, so it's a Pythagorean triple. So I've got 12, 35 and 37. Okay, now I still think there was quite a leap that we made in order to get there, but we're still just following the clues that they've given us in the explanation, the kind of this section here, and we're just applying the same idea, and we're going to try and piece this together and spot patterns soon. So again, let's just do what it asks us to do. Find the sum of 1 over 9 and 1 over 11. 1 over 9 plus 1 over 11 is equal to, it's going to be over 99, isn't it? And so we're looking for, I think, an 11 plus a 9, which is going to be 20 over 99. Can a Pythagorean triple be formed? Well, let's just see. So what I did previously was I took the two numbers that formed my fraction and tried to see if it gave me a whole number result when I applied it to the shorter sides of a right angle triangle. So that would be square root of 20 squared plus 99 squared. Tap that into your calculator and it gives me an answer of 101. So therefore that implies yes. I was kind of expecting it not to give me one, but it did, so that's fine. We'll go with it. Have some trust in what we're doing. Okay, for some values p and q, the sum of unit fractions can be used to form Pythagorean triples. Okay, so we've seen that. Write a single algebraic fraction 1 over p plus 1 over q. Okay, again, let's just try it. Let's give it a go. So what we've got here is as a single fraction, let's write it equals here. Equals, that's going to be q plus p over p, p times q. And I've pieced that together in exactly the same way as I did previously. And that's going to be my final answer. Just copy it down. What did I say? Q plus p over p q. Now, what's it going to be then? So now these numbers, top and bottom, formed part of my my Pythagorean triple, and they were just these two numbers on the numerator and the denominator. So my numerator is q plus p, and then I've got pq. Now interestingly, we've been given this pq plus 2. So what I would do is I would look back and see, well, does that kind of make sense in what we had previously? Well, it kind of does. If we look at these numbers that we formulated, we got 35 and then 2 more is 37. We had 99 and then 2 more is the 101. So it looks like we are finding exactly that. Well, it didn't quite work here, so something unusual was happening here, but okay, that's fine. In terms of p's and q's and the pq plus 2, that kind of holds true. Now that's the end of where we're taking this for this practice assessment. The full paper I'm going to continue now just to show you, but it requires a little bit of algebra that we're going to study later in the year. So yeah, let's have a go. Okay, so by applying Pythagoras' theorem to your answer in part 2, show that this equals this plus this. Okay, so I'm not going to think about it too much. I'm just going to apply Pythagoras' theorem. So we've got, what have we got? First number is q plus p. So we've got q plus p, which we're going to square. And if we add that to pq squared, that should equal pq plus 2 squared. Okay, now there's quite a lot of algebra to figure this out, but we can do this as q squared plus 2pq plus p squared plus p squared q squared equals, now expand this bracket, p squared q squared plus 4pq plus 4. Now let's just have a look what I can do to both sides. Let's subtract 2pq from this side and subtract 2pq from this side. Let's subtract p squared q squared from here and also from here, minus p squared q squared. So I'm going to do two things in one go and see what I'm left with. So that should give me a p squared, or a q squared. I should write first read, shouldn't I? So it should be a q squared plus p squared is equal to, this one's disappeared, 4pq minus 2pq gives me 2pq plus 4, which is the same as what I've got, except my p's and q's are a different order. So p squared plus q squared is equal to 2pq plus 4. Now there's a really important point that I want to emphasize on how you approach this type of question, because it's telling you what you need to do and it's telling you what your answer should be. And a lot of students will get this the wrong way around. They'll start with the answer and plug in some value for p and q and try and show that it works. That's not going to get any marks for this. It's specifically asking you to apply Pythagoras' theorem to this thing. This is telling you what to do. This is merely telling you what your answer should be. So when you arrive at your final answer, it should be the same, and you can be confident that what you've done is correct. So just make sure whenever you have a question that says show that, you're not starting with this, you're arriving with it as your final answer. Okay, find two algebraic relationships between p and q so that 1 over p plus 1 over q can be used to form a Pythagorean triple. Okay, so this is, now we're going to look to factorize this. And I was a little bit unsure on kind of how this worked, and I did have to go back and look at the numbers that I'd used previously in order to piece it together before I then kind of spotted how it was going to work. But what I'm going to do is I'm going to use my result that I got previously. So p squared plus q squared, and that was p squared plus q squared. Let's go minus 2pq is equal to 4. Now I can factorize this left hand side as being p plus q, no I can't, p minus q, p minus q, p minus q. Now again, if this algebra is a little bit unfamiliar to you, don't worry, we'll study it later in the year. And this can be written as p minus q squared, that's equal to 4, which means p minus q squared minus 4 is equal to 0. And now we have the difference of two squares, so we can factorize this again. So I would call this p minus q plus 2, p minus q minus 2. And so that has to equal 0, which means that either this bracket can equal 0 or this bracket can equal 0. So p minus q plus 2 would equal 0. P minus q equals minus 2, and so p is equal to q minus 2. And over here we've got p minus q minus 2 is equal to 0. P minus q is equal to 2, so p is equal to q plus 2. So we've got two answers. P is equal to q plus 2, p is equal to q, or p is equal to q minus 2, p is equal to q plus 2. So p is equal to q minus 2, p is equal to q plus 2. And there we go, with quite a tricky finish to this, but this is how you piece it together, using the kind of clues they're giving you along the way in order to piece it together and then apply it into a different context.